Hello everyone. We have this permutation combination problem here, and okay, you can pause the video and read the problem first, and then we'll dive into the solution. So you may find some for this kind of problem there is a direct formula available, but I would recommend going from basics, how everything is developed in that. Okay, so if you go from basics, you see what is being said here. So there is a child which we will write as C1. What is the number of balloons that they can get? 2, 4, 6 till 20, right? Now, many of you will jump into the occasion and say that no, he or she can't get 20 because then others will get 0. And we have to find that when we have to make sure that no child gets an odd number of balloons or no child gets 0 number of balloons, right? Each child gets some balloons at least, right? But don't have to worry about it. As you will go on, we'll move forward to the problem. You will see why that is not an issue. We'll have the 20 here for now. That is a possibility. So what I want you to do is to create a series. So we will create a series. We will write x everywhere, right? And then this 2 will take here, right? Here. This 4 will write here. This 6 will write here. Till this we will write the 20 and we'll add everything. Okay, all right, makes sense. Why we are doing this, I will come to that a little bit later. Now this is child 1. For child 2 we are going to do exactly the same thing. What is the possible number of ways that they can get the balloons? 2, 4, 6 till 20. Okay, all right. Now we can create the exact same series here, right? So till x to the power 20, right? We have this. Now how many series you will create? You will create 4 series, right? 4 series. Now I want you to multiply everything. How you do that? What is the going to be the result? So this is going to be this. First of all, you write everything as is. I'm skipping the x to the power 6 star because you are already familiar with that. So x to the power 20, and now what you will do is to the power 4 because you have multiplied everything, right? Now I want you to look at this particular term. What does it say? So let us say that you want to see in how many ways only 2 balloons can be circulated among all of them. So you can just, in this total term, you just have to look at the coefficient of x square. And what if instead of 2 we have 20 identical balloons? We just have to do it x to the power 20, right? Now let us revisit why we didn't bother about this x to the power 20 term here. Because we are multiplying everything, right? So this x to the power 20 term will automatically get cancelled because there is a x to the power 2 term here, and in the resultant there will be nothing contributing. In the resultant term there is no term of x to the power 20 that will be contributed from here, right? So here is the 1 1 1, right? So again, let me rephrase this. So let us say this one term, if you had only one child, in how many ways you could have given him 2 balloons? 1. So this 1 comes from here. In how many ways you could have given him or her 6 balloons? This 1, right? So when you're multiplying these 4 terms, like this term 4 times, you are accomplishing it for 4 children. Did I make that clear? Okay, just you can spend some time with this and it will make sense to you. Okay, all right, moving forward. Now what we have, this term, this is x square x to the power 4 till x to the power 20, and we have raised everything to the power 4. And what we have to find out? We have to find out coefficient of x to the power 20, right? So let us try to simplify this a little bit. Okay, what you can do is, this is the GP. You can see this is a geometric progression. So the first term is x square. What is the common ratio? X square. And what is the total number of terms? 10, right? Because it is starting from 2 and it is going till 20, right? And all the even terms are being taken, right? So 1 minus x square, this is what it has. Okay, so x to the power 20. Okay, now what you have is, this is x square and this is 1 minus x to the power 20 divided by 1 minus x square. Okay, hopefully this makes sense to you. And what you have to find out, okay, one other thing, you can't forget the 4. This was raised to the power 4 everything, right? This was raised to the power 4 everywhere. Okay, so you have to find out the coefficient of x to the power 20. Okay, let us see that again. So first of all, you take this x to the power 8 outside, right? X to the power 8 outside. Now what you have is 1 minus x to the power 20, 1 minus x square. Again, you can't forget the to the power 4. What you are trying to find out? The coefficient of x to the power 20. Can I say this x to the power 8 term I will omit, and 1 minus x square. Okay. Again to the power 4. I am switching the colors. Okay. So that you don't get confused. Now, if you have this, we have to find the coefficient of x to the power 12, because we have already taken care of this x to the power 8 term, right? We don't need it. Now what is this? This is 1 minus x to the power 20 to the power 4 and 1 minus x square to the power minus 4. Okay, did that make sense? Now what you have to find out? Again, you have to find out the coefficient of x to the power 12. Now you tell me, from this term, what contributes towards the x to the power 12? Only 1, because every other term will be in terms of x to the power 20, which will be too high, right? So simply this is 1 minus x square to the power minus 4. You have to find the coefficient of x to the power 12 in this. Okay, now you have this again, 1 minus x square to the power minus 4. Okay, now again I am just writing this, just keep it aside for some time, that x to the power 12, because we are doing it from the basic, we have to look at everything, right? Because if you once you get hang of it, no, you will not like any other methods. Maybe at this point you might find, it might seem like this is very convoluted, but it is actually not. Just watch this video 2 3 times, you will get the hang of it. Okay, for everyone it works like that. Anyway, I am writing another term for you, 1 minus p to the power minus n. Now I am writing n not equals to 1 and p not equals to 0. You know what this expansion is? If you want to expand this, what it happens? The expansion is 1 plus nc1 p plus n plus 1 c2 p square. Okay, similarly n plus 2 c3 p q. I will write everything in p. Okay, fine. All right, so in each case you just start with nc1, and in each step you like increase this and this by one term. Okay, here can I write the same thing? Let us try to write in the same manner. Okay, this is 1, this is 4c1 x square plus 5c2 x square square, right, plus 6c3 x square q. And by the way, this thing expands till infinity. Okay, so this will also expand till infinity, right? Okay, now in this term what you have to find? The coefficient of x to the power 12. So what is going to be x to the power 12th term? For x to the power 12, we have to do x square to the power 6, right? X square to the power 6. Okay, now in order to do that, what is it? First it's c. Here it will be 6, because this 3 comes from here. And what is the difference in each step? 3, right? 2 plus 3 equals to 5, 3 plus 3 equals to 6. So 6 plus 3, that is 9. Okay, so this is the coefficient of x to the power 12, right? All right, so this is the answer, 9c6. You can write it in another term, another way. Specifically, this is 9c3, right? and this you can write it as 987 by 3 2, right? So simply you can write 3 3, this cancels off, this cancels off, okay? This is 84, okay? So this is the answer. This is how you solve this. Just to reiterate what we did, let us go back first. First, we expressed this for each child a series we have written x square, x to the power 4, x to the power 6 till x to the power 20. Then we multiplied those four series and then we tried to find the coefficient of x to the power 20 there. This is the first concept, and the second concept is this expansion, okay? This expansion, okay? I would recommend you watch this video one or two more times and the whole thing will make sense to you, okay? This way you can solve a lot of problems from the similar kind. One other thing I would like to tell you is that how we could have solved this solved we could have we could have engineered the whole problem in this way is because it is written 20 identical balloons. Whenever there is non-identical balloons, this particular approach will not work, okay? Hope that makes sense to you. Hope this adds some value to you. You can solve it, makes more clear to you. If that is the case, give us some likes and subscribes. It will help us a lot. See you in another video with another problem.